Welcome everyone to this Men and Mice webinar. My name is Jo van Skalkwijk, and I'll be the host for today. Our webinar today is focused on secure bind 9 best practices, and as you know, Karsten Strotman will be presenting the webinar. He's from the Men and Mice services team, and we're just privileged to get to hear from you today, Karsten. Please note that all attendees, all of you out there, you're on mute, but we encourage you to submit questions through the GoToMeeting control panel, as many of you are probably used to using. Now also note this, that we are recording this session, and you can find this webinar along with the slides at our website within a few days. On our website you can also find recordings and slides from our previous webinars, including the What's New in Bind 9.11 webinar that was held recently by Karsten also. So if you drop off this call, then you can take advantage of the recording at a later stage. So I hope you're all seeing Karsten's screen there, and I'm just going to hand it over to you, Karsten.
Thank you, Joanna. So hello, welcome. This is Karsten from the Men&Mice service team, and today I will give you a few security tips on Bind 9 and also on the projects on DNS. So I have a lot of content, so without much further ado, I would like to start. So this is a collection of security best practices from our services team. It's not an exhaustive list, but we think it's a good start. And if you see something that we've missed here and you think it's very essential and people should know about this, please let us know on Twitter. We are available at Men&Mice on Twitter, and we will retweet if all the good tips that we receive, we can expand on our list that we have here. So first topic of 10 topics that I've collected is to keep Bind up to date. And from time to time there are security vulnerabilities in Bind 9, and one would like to have an up-to-date Bind 9 without the security vulnerabilities. I see the people producing the Bind 9 name server, they are very quick in reacting on reports on security vulnerabilities, and they almost immediately update the software and bring out a new package. However, it's up to you, the administrator, to deploy and install these packages in your infrastructure. If you have a package manager for your Linux or Unix operating system, then it's easy. Usually you just have to remember to go there and do an update, upgrade, and or YUM or something similar. There's also, if you run Red Hat or CentOS or Debian, there are ways to automate these updates. So you can go into your configuration of the package manager and have it like nightly check for new packages and install them. You should also monitor for security issues on Bind 9 library dependencies. There are two library dependencies that from time to time have security issues. One is the OpenSSL. You probably have OpenSSL working in your Bind 9 if you use DNSSEC or TSEC. Not all problems with OpenSSL are affecting Bind 9. For example, OpenSSL, as the name suggests, is a library that does the secure circuit layer, today transport layer security, but that is not used at all in the Bind 9 name server. But some aspects of OpenSSL are like creating and checking RSA keys. And the libxml2, this is used for the statistics page. So if you have your Bind 9 server enabled to show a nice web page of statistics, then an error in the libxml2 might be a problem and you should upgrade. ISC has an announcement list for all the security related information. I have that on the next slide, and I really request that you maybe subscribe to that announcement mailing list. It's low volume, it is only about new versions and security announcements, so it's really a good idea to have that subscribed. If you don't get Bind 9 updated by your operating system vendor, for example, if you're running on macOS 10, which had Bind in the older releases but not in the current releases anymore, you either have the older releases which still contain bind 9, but Apple is not updating them anymore, or you have new releases and then you don't have bind 9 in there. There are cross-platform package managers that you can use, which basically enable you to have a package management very similar to Debian or CentOS or Red Hat on the other platforms. One popular is Package Source, which is actually coming from NetBSD, but it works on macOS, it works on all Linux flavors and all the BSDs, and so it's cross-platform, and you can use that to keep your bind and the dependencies up to date. And the new kid on the block is the Nix package manager, which is a purely functional package manager, also cross-platform. That is another option to keep bind up to date. You should consider using or upgrading to a newer version of bind from time to time, especially if you are running one of these long-term support Linux and Unix versions. Why do you want to do this? Sometimes there are new security features which really are useful, like within the bind 9.11 there are now the DNSSEC negative trust anchors that are really, really helpful if you have a DNSSEC validating resolver. Or sometimes there are newer and better crypto algorithms for DNSSEC and for TSEC. For example, there are now new elliptic curves for the DNS signatures. There is HMAC SHA-256 for TSEC instead of HMAC MD5. And in the future, there will be new privacy features coming because they are currently discussed in the ITF, and they will be rolling out in future versions of bind 9. And if you have a long-term support Linux version that is supported for 10 years, of course you can stay for the 10 years with whatever bind 9 came when that Linux version was released, but then you are missing out all the new features, and also it makes the internet as a whole less secure because some of the new features are really, really needed, like the new elliptic curve support, which really, really helps bringing DNSSEC forward because of the smaller signatures and smaller keys, lower and smaller packages. Next topic is about separating authoritative and recursive DNS servers. In the dark ages of the internet, when DNS was conceived, the internet was a cozy little place, and all people almost knew each other. There was no one thinking about security there, and also the machines that were running at that point of time were small. They had memory that was measured in megabytes, not in gigabytes like we have today. And hence the developers of the very early DNS software, like bind, they put both the authoritative function of DNS and the resolver function of DNS into the same product, like bind. But Microsoft DNS is the same. But they are really separate, distinct functions in the DNS infrastructure, and they have very different security requirements. Like an authoritative server gets requests from anywhere in the internet, or can get a request from anywhere in the internet, but his function is very easy. He just needs to look up whatever has been requested in the zone database, which is in memory, find the data, send it out, done. A resolver on the other side is much more complex and much more vulnerable to programming errors and other security configuration errors. So while bind 9 can operate in a hybrid mode, which is even the default, hybrid mode meaning it is both an authoritative server and a DNS resolver, it's strongly recommended that you separate the two functions into logical machines. It can run on the same hardware, with the same operating system, with like containers or virtualization. So here's a hybrid DNS server which has the authoritative function on the top, and it has a smart resolver and the cache data on the bottom, both together. And if we want to split that out, then we have what we call an authoritative only DNS server on the left side and a caching DNS server on the right side, sometimes also called a DNS resolver. And if you have this separation, that has multiple benefits. For example, this is required, this separation is required if you want to DNSSEC validation of your own zones, that is the DNS zones that are stored on the authoritative side of DNS. Also, you can optimize the security configuration, for example, the ACLs, the access control lists in bind, for each function. DNS resolver only needs to get queries from your own client, so you can put in your network access control list there. We will see that later. And on the authoritative server, you can make it open for everyone, but only for iterative queries, not for the recursive queries. It also helps the troubleshooting, because in the logging, you have not the recursive queries from clients and authoritative queries all mixed up. You have a clean separation in the logging, and also makes for easier maintenance. Updates, putting in updates is much easier with this separation. When we talk about separation, process isolation is another topic of security. And the classic process isolation in Unix operating systems is the chroot, or chroot. The chroot confines a process into a subtree of the file system. So if chroot is set up properly, then the process running in the chroot cannot access any files outside that subtree. So here we have a picture. On the left side, we have the full Unix file tree view with the devices, the dev directory, the configuration files in etc, bin, sbin, usr, bin, sbin, and the var directory. And here we have a var change root, and then we have an etc, dev, and var named there as well. And now this is the change root directory, and we can tell bind to enter that change root directory upon start, and then bind will only see all the files and directories which are below that change root, but bind will not be able, for example, to look in bin and sbin, and it also cannot look at the password file in etc. Now, why is this important? If there is a security vulnerability in bind that enables an attacker to enter your DNS server through this security vulnerability in bind, then that attacker can only access the files which are in the change root directory, and, for example, cannot read and cannot break the passwords in the password file. Change rooting bind is easy, at least easy compared with the other daemon processes on a Unix system or with the older bind 4 and bind 8. You start bind with the -t parameter, and then you give the change root directory where you want to change root into. All files that bind 9 needs during operation must be located in the change root directory. So zone files, configuration file, you put that into that change root directory. Also, DNSSEC key files will be there, the journal files for dynamic zones, etc. All file references that you have in the configuration file must be relative to the change root, not relative to the real Unix root, and that sometimes is a source of confusion for some admins. I've seen customers shooting themselves into the feet by not understanding that the change root is actually changing the view of the file system, and only the part inside the change root is visible. Now, some Linux operating systems, hello Susie, they try to mitigate that by symlinking the outside world into the change root or back and forth, and that creates or that sometimes solves this confusion on the cost of having more complexity, and I have found that this unfortunately also often breaks. So better is to have a clean environment and learn about change root, how it works. If you want to change root and you have a operating system that has mandatory access control, like SE Linux or AppArmor, make sure that you use a change root that has the profile in the mandatory access control described, so that it works with the with SE Linux and AppArmor. There are some shortcomings in the change root function nowadays. First of all, change root was never designed as a security feature. Change root was originally designed to allow different releases of the same Unix operating system to be installed side by side and to be run side by side. It was never a security feature. A real root user, super user, that is a user ID 0, can often find ways to break out of the change root. So if the attacker manages to get an access privilege or user permission privilege in the change root from, let's say, the bind user to user ID 0, the root user, then an experienced attacker might find ways to break out of the change root. We have seen that in the past. And also, isolation of change root is only the file system level, not on the process, environment, and network level, meaning an attacker that is able to reach the change root by exploiting a security vulnerability in bind still can see all the other processes in the machine, can even kill other processes even outside the change root, can see the environment and change the environment, maybe change the host name, for example, and also can work on the network level. We'll see all the network cards, network interfaces, IP addresses, may be able to change IP addresses, might be able to use the network to attack other machines. So that is or can be a problem. There are modern alternatives to change root. We can say that change root was the first step, and the new alternatives are really the evolution of the same concept, but just in a much broader isolation functionality. There's first the GR Security Linux patches that have an enhanced change root that also, in addition to file system isolation, they do process isolation and much more. They create something that really is comparable to a container. The downside of GR security is that you need to have a Linux distribution that supports GR security, and none of the popular big ones, no SUSE, Debian, Ubuntu support, Red Hat support GR security in their base installations. There is container virtualization, which are supported by the major Linux distribution and also by FreeBSD and Solaris alumnus, where you have a lightweight virtualization on top of the same operating system kernel. So you cannot run other operating systems, but you can have separate, like multiple separate Linuxes running, and systems like Docker or FireShell allow, or systemd Enspawn allow single applications to be confined in a container, and inside the container, the application and also the attacker making use of a security problem in the application can only see what's in the container, meaning the files that are in the container, which is the same as change root, but also only the process that's also running in the container, the network that is configured to be visible in the container, and the container have their own environment. So they have the same host name and inter-process communication and all that. So it's really, really limited what you can do in a container as an attacker. The benefits of the modern alternatives is much better process environment and network isolation, easier manageability. So even that change routing in bind 9 is easy, administrators usually find it much easier to work with containers, especially if there are management tools around the containers like we have with Docker. And then the separation of the application and the data, like you separate the DNS server, the bind DNS server and all its utilities like dig, NSLOOKUP, NSUpdate and so on, from the data, zone files, configuration files, etc., that enables you a clean, quick rebuild after intrusion. So if you have detected that an attacker has been able to take over a container machine, then with like Docker, and it's much easier to rebuild the machine from scratch, make it clean, and then start the service. Sorry, start the service again. The next topic is DNSSEC. The classic DNS is vulnerable to a large number of attacks, like spoofing attacks against the DNS servers, and DNSSEC adds digital signatures on these DNS data. And the digital signatures can be used by receiving DNS servers to guard against many of these attacks. Today, the DNS root zone in the internet, almost all generic top-level domains, the new top-level domains, and many country code top-level domains are already DNSSEC signed, and also many second-level domains are DNSSEC secured. So it is really an enhancement on overall DNS security if DNSSEC is being used. And Bind really makes it easy to use DNSSEC validation. If you run a DNS resolver with Bind9, the Bind9 comes with a built-in trust anchor for the internet root zone. So if you use Bind9 as a resolver in the internet, there's just one line that you have to put in your configuration. That's in the option block. You write DNSSEC-validation space auto semicolon. That's all. Reload. You're done. So you have then a DNS resolver that does DNSSEC validation. You can check that with RDC validation check. It will tell you that DNSSEC validation is enabled, and if you then do a dig to your server and ask for the AD flag, then and you ask for a domain that you know is DNSSEC signed. Here in my example, I used the root zone, asked for the SOA record of the root zone in the flags. You should then see the AD flag, and immediately with that you are protected against quite a number of possible attacks against the DNS protocol. Having DNSSEC validation is the client side of DNSSEC. Consider also if you might want to DNSSEC sign your zone. DNSSEC signing was really difficult in the very beginning of DNSSEC, like a few years ago. But nowadays, with the modern Bind9 versions, I would say everything Bind 9.9 and upwards is very good there. Makes DNSSEC signing and management very easy. If you are not feeling comfortable to play with DNSSEC in your production environment or your test environment, or if you don't have a test environment, I really recommend coming to the Men&Mice DNSSEC workshop trainings, where you have a place to learn, test, and build routine in doing DNSSEC. 60% or more of that workshop is really hands-on work, where we sign zones, do key rollovers, create problems, and then troubleshoot the problems, and make sure that all the attendees are really good in doing DNSSEC management, are feeling confident to put this technology into production. Also, management of DNSSEC information is can be automated today. Bind 9.11 comes with the DNSSEC key manager that automates the key rollovers, and we have now CDS and CDNS key, which automates the communication between the child zone that is DNSSEC secured and the parent zone that needs the trust anchors. Very important if you use DNSSEC. Never ever store your private key material on a DNS server exposed to the internet. That is the biggest mistake you can do, because it's there. The private key can be stolen there, can be used by an attacker to impersonate you. Should never do that, and there's no reason to store the private key on the server in the internet. We'll see that a little bit later when I talk about hidden primary setup, because the hidden primary setup, that's very ideal to operate a DNSSEC signer. The next topic is minimal responses, and this is about that the original DNS RFC standard, the standard says that a DNS answer carries resource records, which may be helpful in using these resource records in other sections. That means that a DNS server that sends an answer can put in more information than has been requested if the answering DNS server thinks that the additional answer is somehow helpful. And that is the default configuration for Bind 9 and also other DNS servers, but it creates larger than needed DNS answer packages. And large packages are a problem today because they can be misused to launch denial of service attacks to other people in the internet. Here is an example how that works. Because DNS is UDP stateless communication, the source IP address can be spoofed. We see that on the attacker on the left side, that machine is the attacker. that attacker sends a request with a wrong source address. So the sender address is wrong. Actually, the sender address is the address of the victim, and the attacker sends that to some DNS server in the internet. Can be a DNS resolver, an open resolver, can also be an authoritative server, and it is known to the attacker that that DNS server creates a large response package on that query. And the DNS server, getting a query, works on the query, sends the answer back to whatever is the sender address of the query, which happens to be the address of the victim. Now, if that happens just with one DNS server, that's not a big problem. The problem appears if the attacker is able to find thousands of DNS servers, and that's very easy. You can just scan for port 53 and then send the very same query to thousands of DNS servers at the same time. And it doesn't need much hardware. You can do that with a PC and a DSL internet line from anywhere in the world. And then all the DNS servers, they send large big answer package to the victim, and the victim is just drowning in unwanted DNS traffic and is being cut off of the internet because no traffic comes through the pipes anymore. Here we have an example. The green stuff here in the DNS answer, that is what really has been requested, that is what is really needed. And then we have an authority section and an additional section. And the blue one, the additional section, the lower one, the large additional section with the green bullet here, that's not needed. That's just convenience stuff for the receiver, and we can leave that out. To leave that out, we can tell bind to use minimal responses. And when we configure bind to use minimal responses, it will use only the responses that are really needed by the internet standards to make DNS work, but nothing more. And here we see a graph picture of a monitoring system of a large DNS server, and that server had a problem. It was misused for a denial of service attack, for a reflection attack, and the administrator in week 02 implemented minimal responses, and we see here that the bandwidth dropped down and was then a flat line on the normal scale after that. And minimal responses, there's no real downside of doing that. It's very easy to configure, and if you run either a resolver or an authoritative server, it's a very easy low-hanging fruit to harden your configuration of your DNS server. Very similar is minimal any, and this is about queries for type any, which is Q type 255, sometimes also seen as the star, as the asterisk. And if a DNS server gets a query for type any, it will answer with all records matching the recursive domain name and class. So all the names, all the different record types, and these can create really, really large DNS answer packages. So of course there can be all kinds of text records, A records, other records in there. Like you see here in this example, there was a query for Men&Mice.com on a just normal bind9 server without minimal any configured, and the answer for Men&Mice.com any is 719 bytes, which is not ultra big, but it's already quite big. If we configure minimal any yes, which is available with the upcoming bind 9.11 version, it will only return the first entry of an any query, not all of them, and that mitigates the problem without causing much breakage. Usually only older software is affected here, like older QMail, which is also something that people just shouldn't really use anymore. There are new versions out there that don't have this problem with without any queries. And here's the same query, dig Men&Mice.com any again, this time with the DNS server having minimal any enabled, and the size of the query has dropped from 719 to 123. Now that's a difference, a good difference. Also a low-hanging fruit, very easy to configure, but you need to have the new bind 9.11 for this. is something for the future. 9.11 should be out in the next days. Choosing a platform for Bind 9. Our recommendation, we get this question very often. Customers ask us, should I use Linux? What Linux should I use? Should I use Red Hat? Should I use SUSE? Should I use Debian? Should I use FreeBSD? Should I use Windows? We say we don't really have a preference here. It's important that you choose the operating system where you as an administrator are most familiar with, where you know your way around, where you know all the knobs and levers that you can pull and tweak to make the system more secure. Doesn't really matter if you read that OpenBSD is the most secure operating system on the planet. If you don't have a clue how OpenBSD works, Windows might be a much better choice for you. Of course, OpenBSD is good, and I really encourage you to learn OpenBSD and run bind on OpenBSD. But if you don't have that time, or you don't have the motivation, and you know your way around Windows or Mac OS or Linux, please keep that system, make it as secure as possible with all the knowledge you have, and make sure it is well configured. Important, choose a version that still receives security patches from upstream, that is from the vendor or from the distribution owner. It really helps to cut down on the complexity on a DNS server. So we recommend to use a minimal footprint install. That is, don't install GUI on a DNS server. So if you have a Linux, don't install GNOME or KDE or X11. If you have Windows, there is Server Core, Windows version without GUI, and that can be really nicely remote administrated by PowerShell, and the new versions even with Secure Shell. Don't install any unnecessary software like databases, web server, mail server that you don't need there, that might have a default configuration that opens ports to the outside world, which is all attack surface. Also, try to not have development tools on your DNS server, because an attacker can make use of the development tools to create, exploit programs that give the attacker the ability to either get much more privileges on the same machine or attack other machines from the machine that is on. Also, scripting language, please try to minimize the installed scripting language. Don't have Perl, Python, Ruby, Lua, and all the stuff on there if you don't need them really. And if you need them, try to make it that way, maybe through container or change root, that the attacker have no means to make use of that scripting language is installed on the machine. Minimize the open sockets to the internet. A DNS server should only have port 53 open, port 22 for Secure Shell, for remote administration. Try to stay away from VNC, RDP, and something like TeamViewer. Just too much attack surface there. Port 123 for network time protocol should also be there, but maybe only if you can do that with the client side of NTP, then you don't need to open a port. And the precision time protocol, which is working on Ethernet level, might be an alternative that doesn't require any open ports on the internet level, just works on the Ethernet that is on the subnet level and is less has less attack surface. Have a plan for recovery. So after you detect a security breach, you shouldn't put just the compromised systems back in business. It's very, very difficult to clean a compromised system. And even people that do that all the time, they say it's no worth to try to really clean a system. It's much better to rebuild the machines, that is, make a clean install. Doing a clean install really is much easier if you have already orchestration tools, something like Ansible, SaltStack, Puppet, CF Engine, where you have your rules that describe how your DNS server should look like, what packages should be installed, what configuration should be in there, because then rebuilding a machine is a matter of minutes. If you do that all manually, can be a big pain, especially if you have no documentation. If you need to restore from backup, then try to restore only non-executable content, so no programs, no named, dig, NSLOOKUP and stuff, and no scripts. If you really need the scripts and you just have them in the backup, you don't have like good versions that you know somewhere in a secure place, then do a peer review with a colleague of all the scripts and configuration files. It's much easier to spot backdoors that the attacker has left in configurations or scripts if you look at that with more than 2 eyes. Having a hidden primary setup can also really help minimizing the attack surface on your management server. With a hidden primary, you have the machine where you do all the management of the zone content, that's the DNS content, on the internal network, which is green here. And the internal network is not reachable from the internet at all. In the DMZ, the demilitarized zone, there's either a firewall or a gateway DNS server that just relays from the internal to the outside internet. And then on the outside internet, we have the secondaries that are listed in the delegation information of the parent zone. So the NS records of your zone list only the 3 machines that is seen in the internet. These machines are very, very minimal. They just have a bind name server, SSH, and maybe NTP. There's no GUI there, they are hardened, and they don't have DNSSEC keys, they don't have anything that an attacker can use to make invasion work. You should monitor your DNS servers to get information on when something goes wrong. Very easy monitoring is check for the AA flag responses from the zone on your authoritative server, that is your own zones, and on the DNS resolver, check for AD flag responses for important queries. It is 4 zones that you know are DNSSEC signed, maybe the top-level domain you are in, maybe the root zone, and maybe a few DNSSEC signed zones like IC.org, and that will give you information whether your DNS resolver is still working correctly and does proper DNSSEC validation. We will have an upcoming webinar this year which goes solely on DNS and DNSSEC monitoring, and there I will also show you some tools that you can use, open source tools that you can use to do DNS and DNSSEC monitoring. Process image hardening. Linux and also some other modern Unix operating systems like the BSDs and Solaris, the program binaries can be hardened at compile time. This hardening usually has a very tiny performance hit or impact, so you might lose 2 to 5% of the performance speed of your DNS server, but with modern hardware that's hardly measurable. But it really enhances your security because it makes it much, much harder for an attacker to exploit a security vulnerability. Unfortunately, not all distributions enable all these security features. Some features where I look to is the railroad feature, which is a feature that secures information in the binary that is used for relocation, that is the information to the operating system, how to move bits and pieces of the program around in memory. Then is the PEI, the position independent executables, which also allow the operating system to load the binary on different spaces in memory. Without PEI, a bind name server of a certain version of a certain operating system will always load at the same memory location, and that makes it easy for an attacker to know where to jump into, like a buffer overflowed a memory location, or a stack or a heap that has been smashed. ASLR is the address space layout randomization, very similar. It puts the heap and the stack of functions on different memory locations, also makes it harder for the attacker to know where to jump to. Fortify source, it adds an additional security checks by the compiler. For example, reads on an array or writes on an array will have an extra check whether the read or write is beyond the index, the size of the array. Then there's stack protector or stack canary, which can detect and mitigate stack overflow attacks. It basically checks after each function if the stack information, if the return information to jump back to the main program is still intact or whether it has been overwritten. And then there is non-executable NX, which is sometimes a software, sometimes a hardware feature that allows to tag memory as being only data memory and not executable. And stack and heap should be marked that way so that an attacker tries to jump into data that is located there in order to exploit a security vulnerability. Then the process, so the memory management unit on the processor will just terminate the program and disallow the attacker to continue. Modern hardware like Intel 64-bit machines and AMD 64-bit machines and ARM machines, they have this in hardware. On older processor types like 32-bit types, this can be emulated in software, which is a little bit slower, but still it adds to the security. Some years ago, I've written a blog post, the link you find here, about the compiler options. If you're interested about what's possible and how to compile with these things, you can check out the link here to my DNS workshop blog. There is the checksec script, which you can download from www.trapkit.de. It's just a shell script. You can, for Linux, you can download that, execute that, point it towards the user ashbin named, and it will tell you for your distribution, for your bind installation, whether some of these security features are enabled. And this here is from a Red Hat 7 system, and Red Hat 7 has all the features enabled. So there is a full railroad, there's a stack canary, there's NX enabled, there's P enabled, rpace and run path. These are two functions that you want to have a node there, which is hard-coded libraries which are in the binary, and usually that's something that people don't want for security reasons. So having a no on the last two items is good, and then the file is user ashbin named that has been checked here. Access control in bind 9. Bind 9 for a resolver without zones. That is a purely DNS resolver. You should restrict networks that can use the resolver with allow query, and then you put in a network block ACL of your own networks in here. You can even have multiple network blocks just with semicolons separated. If you have a bind 9 server running as a hybrid, that is a resolver and authoritative zones, you should restrict the networks that can make recursive queries to the resolver, that is allow recursion, and then your net block ACLs. If you run an all authoritative only server, it's safe to disable recursion, and then nobody can send recursive queries to that name server. That prevents someone from the outside to misuse your DNS server for attacks, and also it also limits the attack surface that attacker can have on your DNS servers. For communication between DNS servers, either your master and the secondaries, or even your server and maybe some forwarding server that you use, you should use TSIG, transaction signatures, on the data. You do that by creating a TSIG key. A modern bind version has this TSIG-keygen utility. You just call that in the command line, and it will spits out a key configuration that you can copy and paste into the named.conf. And then in the server clause, you can have multiple of these server clauses. Server, then network block or single IP address of the server or your servers in the data center. You define then that this server, where you have the communication, will always use this key to secure communication with the remote server. You have to configure the key on both sides. You have to have a symmetric server configuration there, and then all the communication, which is SOA queries, notifies, zone transfer between two servers, are being secured by TSIC. Now, one of my topics that I really often stress in the trainings, but also have mentioned this in the webinar series, is that using a local private top-level domain for the internal namespace is a very bad idea. It goes wrong, and still we see so many customers having this set up because they thought it's a good idea at the beginning and they have no means to move away from that. So having something internally like .company, .local, .lan, .work, or whatever name of your company is just a bad idea. Don't use the private top-level domain. Why? These are not delegated from the official routes. This creates delegation and lookup issues, which are very hard to troubleshoot. Also, if you enable DNSSEC, you get then authenticated denial of existence from the root DNS servers that are proving that the domain you're using does not exist. And then all the DNS servers that do DNSSEC will refuse to answer any queries which contains your top-level domain. It's almost impossible to prevent data leaks. If you use a private top-level domain, that name of the top-level domain will eventually leak out to the internet and will tell people out in the internet information about your internal structures, IP addresses, maybe functions of servers internally. You don't want that. Data leaks are evil. And there are possible collisions with new official top-level domains. The new top-level domains are coming more and more every month. And you don't know what will happen in 2, 3, 5, or 10 years. might just go on and on creating new top-level domains. And at one point, it's your internal top-level domain that now exists in the internet. And then you cannot reach, or your users cannot reach the internet top-level domain because it's also your internal domain. But also, if there's a collision, there is the real chance that the data that was formerly only internal then goes out to the internet and reaches the owner of that new top-level domain. Speaking here about emails, I've seen that people had their own top-level domain, and then the same top-level domain suddenly existed in the real internet, and then mail routing just got weird, and the mails were not routed to the internal service anymore, but then to the internet, to the owner of that new top-level domain. That's not good. You don't want to explain that to your business owners. This is a statistics from one of the root name servers, and we see there a lot of these supposedly private top-level domains that are sneaking out to the root server system. We see .belkin, home, local domain, .lan, all corp, .domain, all stuff that shouldn't be there, but it's leaking out, and it's leaking in a rate of 10,000 queries a second. So it's not a minimal problem, it's quite a large problem. So what should you do if you don't use your own top-level domain, but you want to have your private namespace internally? So our recommendation is to register a second-level domain on the internet, just an official, normal second-level domain. There's now an abundance of choice thanks to the new top-level domain and even short names. So if you think that, okay, I want to have a short name, I don't want to type so long names in my internal infrastructure, look at the new top-level domains. You find 3 or 4 letter names there with short new top-level domains. They are not expensive. Normally range between $9 and $50 a year, which is not big money. It's much less than the trouble you have when data is leaking out. Then you delegate that zone in the internet to a dummy empty zone on a server on the internet. Many registrars do that out of the box when you register a domain, so you don't have to do that most of the time. And then you use the domain internally in your internal namespace, and it's all good. Because that domain really exists in the internet but is delegated to a dummy empty domain, there's no danger that any data is being leaking out, because DNS resolver will just see, oh, it's empty, that domain in the internet, will not like deliver mail there, will not send web requests there. So that was the security overview. Bind 9 tips. Very short, what's next at Men&Mice? We have the Kia DHCP classes coming up in October. Kia, the new DHCP server from ISC, the successor of the good old ISC DHCP. If you want to learn what's different, what's new, what you can do today with Kia DHCP, come to our trainings, either West Coast, USA, East Coast, or to Amsterdam in the Netherlands. It's 2 days, it's all hands-on. And then we have our DNS and bind classes, also again in October in Arlington, New Washington, and there's one in Germany at Linux Hotel. And our next webinars, we are working on a couple of new webinars. The next webinar on DNS, now I'm lost because I always have trouble to speak that word, recurrence. It's we will have an interview partner there, and I'm still negotiating with my guest here for time. We will announce that webinar early, like 2 or 3 weeks. It probably will be in the end of September, beginning of October. It's about fighting spam with DNS monitoring data. So that's interesting. If you find email spam, what you can do by looking just on the DNS data to detect spammers and feed your anti-spam systems with the data you collect from DNS. Then we have one about DNS and DNSSEC monitoring, which probably will be end of October, beginning of November. And then there's another one about DNS high availability tools, which will feature the new DNS dist tool from PowerDNS. That will probably be end of November or December-ish time. Please monitor our webinar website. All the dates will be there, hopefully over the next week or 2 weeks. Or subscribe to our Twitter channel, and we will always post new webinars on the Twitter. That concludes my webinar for today. Johanna, do we have any questions today?
Thank you, Karsten. That was very interesting, jam-packed, full of lots of useful information. We do actually have several questions. One even came in before we actually started, so I'll just start with that one, going right to before the beginning. And it's a question to do with CentOS 7. And the question goes like this, and please excuse my pronunciation, also if I make a mistake here and there. Well, the question goes like this. My DNS servers are CentOS 7. Their bind version tends to be relatively old. Is there a YUM repository you can recommend for keeping up to date? I'd like to be closer to the latest bind version that Men&Mice 7.2 or later supports.
I'm not aware of a YUM repository that can be used. Men&Mice is building RPMs for CentOS 7, which is supported for customers that have a support contract, but everyone else can just use that service as is. So you can download RPMs from packages.menandmice.com. And we always have the latest bind versions there as an RPM for CentOS 7. We have been thinking of putting on a YUM repository with our bind versions, but we have just been busy with other stuff. So it would help probably if more customers would get a service contract for CentOS and bind, which will give us more internal not motivation, but we can better justify working on setting up a repository server for that. but today it's workable, just that you don't have it in YAM. You have to download them manually to your servers and then install them there.
Okay, thank you, Karsten. There's another question, some request, which is please touch on SOHO type configurations that are recursive for the internet and authoritative to the local LAN.
Let me grasp this question for a moment.
SOHO type configurations,
yeah,
that are recursive for the internet and authoritative to the local LAN.
Yeah, these are these kind of hybrid configuration that I talked about, which are possible but are not recommended because it's much harder to get a security right in these situations. What you can do is to have two binds running, like if you have two network cards in your machine that is running the service, you can have one bind started as the authoritative server, listening to one network card and one IP address, and you have another bind running then the recursive function listening to the other address. I even had a similar configuration at home where I just had one network card, and on most operating systems you can bind multiple IP addresses on the same network card, and then I've configured bind to listen authoritatively on one and the recursive function on the other. And then I had the ACL configurations here in the slides. Then you put the recursion node on the authoritative side and the access control, the allow recursion and allow query on the recursive side on the configuration. I take this as an idea maybe to write a blog post with more details on how that configuration will work. So I make a mental note. I don't promise anything, but I make a mental note here that I put that on my list of blog posts for the Men&Mice blog. And maybe I find time next week or the other weeks to write that. Please monitor the blog. If I do so, it will appear on Twitter and on Facebook and all the social media we have.
Okay, great. As long as you promise to put a beautiful picture of your diagram of your home network, Karsten. So, no, we'll keep an eye on that.
That will be not nice. It will be rather complex because I try to build extra complex things to learn. Because how I learn is I build things, I break them, and then I try to fix them, and on the way it's the best way to learn, by breaking and fixing things.
Absolutely, I couldn't agree more. Although with buildings and such, that maybe might be a little bit confusing. Anyway, there's a question here on GeoIP. I use GeoIP in options. Should I copy those files inside the change root, geoip.dat, or use a soft link inside the change root pointing to the real files? So it's quite specific about GeoIP.
No, yeah, it's about GeoIP, but this is general rule for change root and data. You have to copy them into the change root. A soft link will not work. Because the soft link will just point to nowhere because the outside files are not visible for any process running in the change root. So you have to copy them really physically into the change root. Don't try hard links. Hard linking between change root and in and out the change root, that is creating a gateway which an attacker can use to break out the change root. That's not a good idea. So best is to really copy them physically into the change root.
Okay. Karsten, there's two questions here, but related, I think, maybe to your previous webinar rather. It says, what impact does bind 9 have on DNS load balancing, and how does bind 9 handle DNS redirection?
Okay. Yeah, what impact? On alone, bind 9 has no impact on DNS load balancing. You can use bind 9 with load balancing, and I recommend DNS load balancing on the resolver side. So if you have a very busy internal DNS structure, like if you are a provider with a lot of subscribers, DSL or cable subscribers, you want to have possibly a load balancer in front of your Bind9 resolvers. For authoritative servers, the DNS protocol itself has some load balancing built in, which is usually much better than having a physical load balancer in front of an authoritative Bind9 server. So on that side, I would rather recommend to just rely on the built-in load balancing that is in the DNS protocol. That was question one. For the load balancing, that will be topic of the high availability webinar end of November, December. So I hope that I will have more detailed information on that in that webinar where I talk about the different load balancing high availability. The next question is about how Bind9 handles DNS redirection, and that is probably a question about it is possible in Bind9 to have a policy zone that for example, denies the access to certain domain names, and these domains can then be rewritten, or negative answers can be rewritten to positive answers pointing to a different IP address, something like that. This is Bind9 response policy zones. Bind9 supports that. There's rather a lot of what you can configure on that side. That would probably also something that we could handle in a different webinar. It's too much to just explain now. But if you want to have information, look for RPZ, response policy zones in Bind9.
Okay, perfect. Karsten, it looks like we've still got questions coming in, so we've got about 6 questions. Furthermore, would you like to go into all of those?
Let's try.
Okay, the next one, ACL for recursive server. Wouldn't it be better to also set allow query with an ACL, not just allow recursion?
Depends on the function of the server. If I had the allow recursion on a server that is a hybrid server, also has authoritative zones, so it needs to have the ability to receive queries from all of the internet, because you don't know from where queries will be coming from. So you can only restrict allow recursion. If you have just a recursive server which has no authoritative zones, then you should use allow query, because then you really know who will be sending queries, which are your clients. So it really depends on the function on your server. If it is a DNS resolver only, use allow query. If it is a hybrid, use allow recursion.
Okay, I think that's quite a clear answer there. So next one we'll go to is, if one decides to use recursion in the named.conf, wouldn't he have to use forwarders pointing to reliable servers, or would he build a second set of servers to do recursion for his inside user?
Recursion no is what you should do on an authoritative only server. So that server will never get queries from client machines, will only get queries from servers in the internet. Yes, there should be other servers that are then the DNS resolvers. They don't need to be forwarders, just normal DNS resolvers would be just fine. So yes, it is a second set of servers, but it doesn't need to be a physical server, so it can be another bind running on the same machine, just with a different configuration, or to make it easier, having a container, one with the authoritative, one with the recursive service.
Yeah, I think that explains it all. So there's a request that came in here. It said, I did not see mention about implementing split-brain DNS to cloak internal DNS resource records from the internet. What are your thoughts on the security infrastructure, and what is the optimal configuration or server topology to set this up?
I mentioned, actually I had something like split brain in there, but I just didn't use that that name. That was about the local private top-level domain. what my recommendation here is to use a namespace that is registered in the internet. So don't use names that don't exist that you don't own in the internet. Get a namespace that you own in the internet, use that internally, and configure that on your DNS resolvers. What I haven't covered here is really how a configuration would look like on a DNS resolver to have a gateway that will redirect internal queries to the internal authoritative server and let all other queries go out to the internet. We had that in the previous webinar, but I don't remember which one that was. I'm happy to do that in one of the next webinars to show configuration there.
All right. There seems to be plenty of material for about, a webinar a day, Karsten.
Yeah.
So how do I identify private or public key files on my bind servers in the DNSSEC keys directory? How to store them elsewhere? How is that possible?
The public-private keys have different file name endings. So if you have a DNSSEC key pair, one is with the ending .key, which is the public key, and one is .private, which is the private key.
Yeah.
So that is how you identify private and public keys. You can also look into the files. They are text files, and they have some comments at the beginning saying this is a private key or this is a public key. You can also read what's in the keys. How to store them elsewhere? It's okay to store them on a DNS server as long as the DNS server is not exposed to the internet. So I had in this slide deck the hidden primary master setup, and that is the setup that I would recommend for DNSSEC. Having the keys on the internal server, which is in the green internal network, is just fine, because nobody from the internet can access that network and that server and steal the keys. They shouldn't be on servers that are in the internet, directly reachable in the internet. If you need more security, there are hardware security modules, which are sometimes rather expensive hardware boxes that you can buy from different vendors out there. They cost from like $10,000 US up to $200,000 US, depending on the feature set. And these machines are built to keep the keys secure. So the keys are being generated in these devices, and there's no way to ever get the keys out of the device. And you then configure your bind name server to talk to that device. Whenever bind needs to have the private key, then bind sends the data to be signed by the private key to that device, to the hardware security module. The hardware security module does the signing and then spits out the signatures, and bind just mixes that signature in with its own information. That is what the top-level domains use and what banks and other high security setups use. It's probably not needed for everyone, so having a hidden primary master is good for, I would say, most installations.
Okay. I seem to have skipped a question that was earlier on, Karsten, about what responses would be considered not minimal, in other words, be excluded from your discussion. It's way back into the slide, so maybe that's a lost question. No?
Let me give an example. If you ask for the mail server of an outside domain, you ask for the so-called MX record, the mail exchange record. Yep. Let's say there is an email to be sent to google.com. You ask what is the MX for google.com, and in a non-minimal answer you would get the names of the servers, and you would also get all the IP addresses of the servers. In a minimal answer, if you have minimal yes, then only the names of the servers would be returned, and the receiving DNS server would need to go and ask for the IP addresses himself. Now, usually companies have more than one mail server. Let's just pretend Google has 5 mail servers. That would be 5 MS coming back, and each of these MS records might have 1 or 2 or more IP addresses. So that gives a rather large answer.
Mm-hmm.
When in minimal answer, the answer is just having the names, then the receiving mail server will just pick one server, and then there will be just one query for that one IP address, or the IP address for that one, giving 2 round trips. That's a little bit slower than before, but not much, but much less data that flows over the wire and smaller answer packages. I hope that makes it a little bit clear how minimal answers works.
Definitely, it's I'm sure it does. And well, let's go straight on to the last 2 questions. There's only 2 left. No, someone threw one in right there, so it's 3 left. And the third last one is what version of bind is suggested for maximum security in a new DNS deployment? Open source, ISC bind, or a third-party vendor, for instance, Oracle bind? What would you suggest?
I might be a little bit biased here. I would always choose the open source ISC bind because my experience is that the patches for security vulnerabilities are quicker available with the ISC bind. Usually you get them you can download them on the day where the security vulnerability is public. If you get a support contract directly with ISC, or you can even have that through Men&Mice, you get a 2-week warning usually for a security vulnerability, and even get the patches 2 weeks before the rest of the world will be getting them. You have to sign an NDA for that because that information about security vulnerabilities needs to be kept secret. But that gives you a head start as an administrator. You can always already patch your systems before the security vulnerability is out. Now, you might get the same from Oracle, but I'm not sure about that because I never have used Oracle bind. What I know is that if you have a third-party vendor that makes any changes of bind, usually it takes a few days more for them after IC releases a patch for them to integrate in their version and then do their quality testing and release then their version.
Okay. Well, maybe we should just ask the new CEO, Karsten Magnus. He spent quite a few years at Oracle, so maybe he'll give us the answer about Oracle bind.
Yes, but Oracle is a big company. I'm not sure if he worked with Oracle bind.
We'll have to find that out. Anyway, the next question: do you have any recommendations on the mname server in the SOA record when using hidden master configuration?
Yes. The mname field, actually, the mname field is only really required if you have dynamic updates. And dynamic updates, with a hidden primary master, you probably do that also from internal. You don't want to have updates coming from the internet to your name server. So if you use dynamic updates, you put the really name of your hidden master in the mname field, but then the same name is absent from the NS records. So you have the host name of the internal machine in the mname field, and then you have the outside machines in the NS record. That's just fine. If you don't use dynamic updates, you're just free to write in the mname field whatever you like. It's not used. You just have to have something there, but you can put foo.bar in there.
Food.bar. Okay, anything like that. Okay, Brendan, I noticed now that one of the, which I thought was a question, was just a suggestion for a future bind webinar to do with proper use of SOA field values. And you probably noticed that, so we'll pay attention to that in the future. And then we had a comment from one of the attendees who just said, thank you very much, very useful information. I think I speak probably for everyone if I say, well, I feel the same. Thank you very much, Karsten. That was very useful. And I would remind everyone that the recording and the slides of this webinar, as well as all previous webinars, are available at menandmice.com, and this particular webinar's information, recording and slides will be available from next week onwards. So don't miss the opportunity to download it and have a second look if you'd like to. Once again, thank you everyone for attending. Very nice having you. I hope everyone goes into the fall filled with the joys of what summer gave them. And Karsten, thank you very much. We'll speak again soon.
Thank you, Johanna. Been a great webinar.
Same here. Thank you. Bye.